Welcome to Summarize Science. Today we are looking at a fascinating new paper that investigates whether AI video models actually understand the rules of our world. The researchers introduce a concept called reasoning coherence, which is the ability of a model to keep events logically consistent across frames. They developed a benchmark called MME-CoF-Pro to put current AI models to the test. To get a full picture, they tested models across 16 different categories. These include everything from 2D geometry and object counting to real-world spatial reasoning and physics. The goal was to see if the models could simulate complex actions like a gripper placing a spatula on a pot or a car moving in a straight line. A key part of the study involved giving the AI different types of help, or hints. They compared how models performed with no hints, with specific text descriptions, and even with visual guides like red arrows and bounding boxes. This allowed them to see if better instructions actually led to better reasoning or just better guessing. The researchers found that there is a major decoupling between visual quality and reasoning ability. Just because an AI can generate a beautiful, high-resolution video does not mean it is following the laws of physics. In fact, some of the highest-rated models for visual quality scored very poorly on logical consistency. To measure this, they used something called a reasoning score. Instead of just checking the last frame, they broke every task down into human-validated steps. If a model missed one of these intermediate steps, its reasoning score would drop, even if the final result looked okay. One surprising finding was how text hints affect the AI. While adding text hints usually improved the reasoning score, it often caused the consistency score to crash. This means the models were so focused on following the text prompt that they forgot to keep the video itself stable and realistic. Look at these failure examples where models like Kling prioritize pretty movement over actual instructions. In one case, the AI was told to zoom in on a handbag, but it spent more time simulating wind dynamics in the trees than finding the bag. In another, the AI hallucinated a second character just to complete a movement task faster, which broke the logic of the scene. Visual hints, like red arrows, also had mixed results. They were very helpful for tasks involving space and direction, but the AI sometimes got confused. In several instances, the model actually tried to draw the red arrow as a physical object inside the video rather than using it as a guide. To recap, the MME-CoF-Pro benchmark shows that today's AI video generators are great at making art but weak at reasoning. Text hints can boost performance, but often lead to strange hallucinations and visual glitches. Visual hints are great for navigation, but are often misunderstood by the models as part of the scenery. In the future, this research suggests we need models that are trained to truly ground their actions in physical reality. Developing AI that understands why things happen is the next big step toward reliable technology. Thank you for watching Summarize Science, and stay tuned for more breakthroughs in the world of AI.